Alrighty, I'm Justine Dean. I'm one of the flight nurses for Apollo MedFlight, and I'm going to briefly discuss with you guys anatomy and physiology of the skeletal system. And this one's not very long, but there are a lot of good key points to remember, a lot of terminology that we need to be familiar with that's going to help us through our course of treatment. This presentation was written by Red River Medical Institute, Leanne Jones and Chuck Skinner. So as far as the skeletal system goes, you've got different terms that are going to describe the type. So axial is going to be the line up vertically for support, parallel to the center of gravity. Appendicular, primary limb and girdles. Attached limbs to axial skeleton. And then just a little keynote, there are 206 named bones. The function of the skeletal system is mainly movement, support, organ protection, production of blood cells, mineral storage, and lipid storage. You have the gross anatomy, which include flat bones, which parallel the surface of the hard bone. They protect and have a broad attachment surface. Long bones, they do more of the weight bearing. Curved and strong, they're both compact and spongy. Examples of those could be your limbs. The flat bones would be more like your scapula, things like that. Short bones, they're compact on the surface with spongy centers. They're cuboidal. Wrist and ankle bones are short bones. Irregular bones, examples of those, and your facial bones. Sesamoid bones, they're going to be buried in tendons. They can change direction as a pulley does. So think of the patella when you think of bones that are sesamoid. Some more terminology, the diaphysis. Dia is going to be through, and then physis is growth. Long section of the bone. And this is just a depiction of growth plates, bone formation, blood vessels, and then a mature bone and bone marrow production, or bone marrow housing. A metaphysis, meta is going to be after, the immediate area between the diaphysis and the epiphysis, where growth occurs in very, very young children. That's why it's important to remember that whenever children break bones in various locations, based on where it's at, if it does go through the growth plate, they could have stunted growth as a result. Your epiphysis, epi, is going to be above or outer in the end of bone. So this picture just depicts joint cartilage, new cartilage forms on the side, and then where it is as far as the growth plate. Your periosteum is going to be the fibrous covering of, and it's going to be the source of vessels and nerves that go to and from the bone. Your articular cartilage is the lining of the bone at the joint with another bone, and it allows for frictionless movement. So in any areas that you have your joint, your elbow, knees, things like that. Marrow cavities, the center is going to be hollow within the diaphysis, and it's going to be where the RBCs and WBCs are produced. Mainly, it also houses the bone marrow. So when they do like an aspiration, that's where they try to get into to pull that out. Or whenever you do an IO, that's the cavity that you're trying to get into because the area, including the marrow that's in there, also your vessels are there so that your medications can get in there. There's not a whole lot of space in marrow cavities. So whenever you do first inject either saline or lidocaine, painful because of the expansion of the components that are already in the marrow cavity. As far as blood supply in the skeletal system, nutrient arteries enter through the diaphysis. The epiphyseal artery enters through bone ends, and then the periosteal artery nourishes the periosteum. The picture depicts different types of stress that can be placed on the bone that could result in fractures. So if you have compression, that's going to be the two pressing together. Each of these are color-coded, but I will go ahead and highlight those for you. So the compressing together would be end to end. The tension would be pulling apart. Torsion would be more of a twist. And then a shear would be the tearing across the bone. Surface markings of the bone. The tuberosity is the roughened, rounded knob. The tubersole is the small knob. A spinous process is a slender projection. The trochanter is going to be the large projection of the femur. A condyle is the large knob or rounded surface. And then the epicondyle is going to be a smaller prominence above the condyle. So remember, epi, above, right? As far as a faucet, it's a flattened surface of a joint attachment. The crest would be so think of like the iliac crest. That's going to be a rounded area. A sinus is a hollow space. Those are mainly in the face. You can find a lot of sinuses that are present. A meatus is a tunnel or a canal. A fossa is a depression. A foramen is a hole or opening, and a fissure is a cleft. Some of the microscopic anatomy that we need to be familiar with: originator cells. They have multi-potential. Osteoblasts are going to be your bone-forming cells, and then your osteoclasts are your bone reabsorbing cells. Osteocytes are mature cells trapped in matrix. And soft, strong can support and reinforce mineralized matrix. Some commonly used terms. This is going to be what we're going to focus on a little bit more. These are going to be more familiar to us as far as everyday practice. A reduction is going to be the reestablishment of normal bone position. And you can have an open reduction or a closed reduction. That just is going to depend on how extensive the injury is and how they want to go about repairing that. A dislocation is going to be a displacement of a joint, a bone from a joint. A fracture is a broken bone. Internal fixation is going to be surgical placement of steel material into the bone to hold it in place. And it can be done surgically or through fluoroscopic guidance from without. Closed will be simple. Those are interchangeable terminology types of fracture. The treatment for those, that's going to be immobilization. So we need to be familiar with that, and we also need to be able to recognize them. Say if we arrive on scene and we're the first ones there, we need to be able to distinguish that or make an educated guess about what's going on. Open or compound, those are also interchangeable fracture. The treatment involves surgical repair and debridement and reduction, as well as immobilization. And typically they are open. So. Impacted fracture, they're going to require immobilization and repositioning. Comminuted fracture, bone shatters into small fragments. Treatment is varied, and saving as much of the bone as you can is going to be the main goal, trying to put it back to where it belongs. Pathological fractures, this is it occurs secondary to a weak spot in bone, such as a malignancy. That's going to require internal fixation. A green stick fracture, which we see a lot in children, it's going to be an incomplete fracture with part of the bone act, common in children. The goal of that is immobilization. Stress fractures are going to be tiny hair-like fractures from repeated insult to a bone or bone group. So somebody that keeps falling and falling and falling, they're going to have tiny little stress fractures in that area. Or as your tibia, so with people who are into running and things like that, they can get shin splints. Your metatarsals from march fracture, like in soldiers, that's what that's keyed for. And that is the end of A&P of the skeletal system.